Okay, this question is from the June 2019 Limpopo paper 2. It's a question about Rutherford and his alpha particle experiment. Now, there's a problem with this question in that in the CAPS document and in the exam guidelines, it says you must know about Rutherford, but like one sentence of understanding his discovery is fine, and this question is 12 entire marks. Okay, so this question is a little bit unfair based on what you're supposed to know. However, most of the marks in this question can be obtained if you use your brain and some logic. Okay, so you can actually pick up a lot of clues in the question. It says to you, during the studies of the atomic theory, Rutherford bombarded a gold foil with alpha particles. The results obtained are illustrated in the diagram. The arrows represent the paths taken by the alpha particles. So I've shown you this exact diagram in class, and I've explained this with the animation of what happened with all of the alpha particles. Now it says to you, write down the X notation for an alpha particle. So if you're confused what's an alpha particle, you can get stuck here. But if you don't give up and keep reading the question, it says to you later on in 5.4, an alpha particle is a helium nucleus consisting of 2 protons and 2 neutrons. So this is down in 5.4, but it can help you over here. So if you want to know what's an alpha particle, it's a helium nucleus consisting of 2 protons and 2 neutrons. This means it has lost its electrons. If it's only the nucleus, it's lost its electrons. It has a positive charge. So this X notation, we discussed this when we talked about the periodic table. If you look at your periodic table, this is how your periodic table is set out, okay? And this is what the exam guidelines say. Represent atoms using the notation, this notation, where E is the symbol of the element, Z is the atomic number, and A is the mass number. So I said to you, if you have a look here, Z is the atomic number, okay? Can you see there Z is on the bottom, but on the periodic table, the atomic number is on the top. So all you have to do is take this notation from the periodic table and flip the numbers. And I did explain this to you when we discussed it, but I know we've discussed a lot of things. So what we're going to do is we're going to take helium. We're going to write He for helium because it's the element. We're going to put the 4 on top because it is the mass number that goes on top, and we're going to put the 2 underneath because it's the atomic number, because that's how this notation shows you. And then, because this says to you an alpha particle is a helium nucleus, we're going to lose the 2 electrons and give it a 2+ charge. So we have to swap the 2 and the 4. We put the 4 on top, the 2 underneath. We write He as the symbol, and we give it a 2 positive charge, because if we've got 2 protons, we have 2 electrons. So if it is the nucleus, we have lost the electrons and kept the protons. And because it says to you in the question there are 2 protons and 2 neutrons, the total mass is 4, as we've drawn here. So this is the Z notation for an alpha particle. Now it says to you, describe the 3 observations that Rutherford made. If you can't remember them, this diagram is supposed to help you, okay? So the 3 observations are that some of the radioactive particles passed through, some radioactive particles were deflected, and some radioactive particles were reflected. So you can see from the diagram it says deflected, reflected beams. And then you can see some passed straight through. So these are the 3 observations. Some alpha particles passed straight through the gold foil. Some were deflected, and some were reflected. Okay? So in the memo it says deflected and deflected twice. They're supposed to be some were deflected, some are reflected, so the memo is not 100%. Okay. Now it says state 3 conclusions regarding the structure of the atom that Rutherford made. So what was the big breakthrough that Rutherford made? Rutherford discovered that atoms had mostly empty space, okay? And how do we know this? Because some of the beams passed straight through. The previous models, packed all of the particles just randomly. They were positive, they knew there were positive and negative things, but they were just all over the place. This orderly scattering and the fact that some passed through completely unchanged means that there has to be empty space, because like charges repel. So if you've got positive and negative, then it must either be attracted or reflected, okay, by the things in the nucleus. But if they pass through, the only way they can pass through is that if there's empty space. So he discovered that there was a positive core, okay, empty space, and that the positive and negative were separated. The positive and negative charges were separated. Okay, so those are his three conclusions, and it's come from the fact that some passed straight through, that's the empty space. Some were deflected, that's when the ray hits a negative particle, and some were deflected is when it is bent by a negative, and reflected is when the positive alpha beam hits a positive nucleus and bounces off because like charges react. Now it says to you, an alpha particle is a helium nucleus consisting of 2 protons and 2 neutrons, which is how we were able to write this down, okay? What is the relative mass of an alpha particle? Show your working. So a proton weighs 1 atomic mass unit. A neutron weighs exactly the same. Okay, so we've got 2 protons plus 2 neutrons equals 2 plus 2 equals 4 atomic mass units. So the relative mass, if it's the relative mass, it doesn't need the units on the end because it's relative to carbon 12 and you're dividing the units by the units. So the relative mass will be 4, and that is your final answer.